Hello. Good evening, everyone. Can you hear me? Good evening, everyone. Can you hear me? Please reply in chat. Okay, Hers. That's fine. Let's wait few minutes so that we can start the class. Okay. Let us start. This is your AC circuit, right? Or AC network. You apply the voltage V, okay, and the current flowing into the circuit is I. All these are AC. That means the network for this networks, the power calculation P is equal to V into I. Let V T, because we are expressing in the instantaneous values, so Vm and cos omega t plus theta V, and It is equal to Im cos omega t plus theta I. Okay. For our convenience, what we will do, we'll shift the both voltage and current by theta I. So I can write V of t is equal to Vm cos omega t plus theta V minus theta I, and It is equal to Im cos omega t, because we are shifting right, okay, we are delaying both the voltage and current by the theta I. Now we can calculate P is instantaneous power Vt and It, which is Vm Im cos omega t plus theta V minus theta I into cos omega t. So I can write that is 2 cos A, that is cos A into cos B. So I can express into the sum of two cosine functions, that is Vm Im upon 2 and cos theta V minus theta I plus, not plus, because cos A plus cos B, okay, yeah, plus Vm and Im, okay, Vm and Im upon 2 cos 2 omega t plus theta V minus theta I. So for instantaneous power I can write this. You can clearly see that, okay, you can clearly see that this part is a average value because it is constant for given theta V and theta I. This is the constant and this is a sinusoidal varying with a twice frequency. So the objective questions can come, the power varies at twice the frequency, twice the line frequency. Okay, power frequency is the twice the line frequency. Line means supply frequency, because you can see easily we have shown it, that is 2 omega. For example, in your domestic supply, the 50 hertz is the supply voltage or current, but power will be the 100 hertz power, instantaneous power, right? So this is your average value and this is the instantaneous value. When you take the average value, average, you know, the average value of a constant is same average value, and you know the average value of a sinusoidal function is 0. So I can little bit arrange it so that you have a very good that is relations for the this instantaneous power. So I can write your P of T is equal to the average value, that is half Vm Im cos theta V minus theta I. So I can write, you see here, this part of the equation, this part Vm Im upon 2 cos 2 omega t plus theta B minus theta I. So what I can do, can you think about that? Cos A plus B. What is the cos A plus B? Anyone know? That is cos A cos B minus sin A sin B. So here is the A 2 omega t and this is your B. Okay. So let us try to write. So PT is equal to this plus, first write the half Vm Im cos 2 omega t plus theta V minus theta I. So I can write half Vm Im cos theta V minus theta I. See, so this one I can write half Vm Im cos theta V minus theta I into cos 2 omega t minus half Vm Im sin theta V minus theta I into sin 2 omega t, right? So I will designate, I'll write instantaneous power small p is equal to capital P plus this term, if it is P, so this is also P, capital P cos 2 omega t minus Q sin 2 omega t. What is P? P is the average power. Okay, P is the average power theta V minus theta I, and your Q is the apparent power. Okay, sorry, reactive power. Apparent power is the product of V and I, that is volt ampere. So it is a reactive power, which is half Vm Im sin of theta V minus theta I. Clear? So let us write the what does signifies the cos theta V minus theta I. We call the PF, that is power factor, which is equal to sin theta V minus theta I. The reactive factor is the sin theta V and theta I. So now we will represent the power, AC power, in the complex power format. This is the instantaneous power. Okay, complex power format. So I can write the complex power that is S, capital S, which is equal to P plus J Q. As you know that anyone can be, P can be positive, negative, Q can be positive, negative, according to the whether the power is being delivered or absorbed. Okay. So you know that in a AC environment, suppose this is your element, which is impedance is equal to R plus Jx. R is always positive and your X can be positive and negative depending upon the lagging load or leading load. So this is, let's say, V effective, and this is current is I effective. So how you calculate the complex power? Complex power S is equal to, because V effective means RMS value, okay, so need not to divide by half, that you should remember. V effective into I effective complex conjugate. V effective into I effective complex conjugate, or just with little bit of manipulations you can write half, half, or you can say we are always writing in the effective term, so you can write I effective, okay, square into Z, that is the impedance, or same as the your V effective magnitude square Z complex conjugate. By these relations you can very well write from this equation, because V effective is equal to Z into I effective. Simple relations. Just put this value here, you can easily get the all other relations. Right. So if they have been given the peak value, so obviously your complex power is simply half Vm Im complex conjugate. Wherever I have written effective, just divided by 2. Clear? There should not be any doubt. Okay. V effective and I effective is the effective value or RMS value. Right? Got it? You are getting it? Anybody has any doubt? Let me know. Hers? Join. I do not see. Okay. Anyway, hers is writing. Okay, please reply whether you are getting the things or not, because it is very important topic. Okay, that's fine. Now move to the power triangle. Power triangle, you know that you have S, which is equal to P, that is average power, and J, Q, that is the reactive power. You know how to represent a complex power in the complex plane? That is P plus JQ. If it is your P, okay, and it is your Q, so obviously I can write like this. This is called the power triangle, and this vector is your S. So in terms of magnitude, this is your P magnitude, that this is your Q magnitude, and this is your S magnitude in terms of length. and this theta is the theta equal to tan inverse q upon p is the, or you can say the cos of this is theta. This is the phase angle between the voltage and current. Theta is the phase angle between the voltage and current, and S is the complex power. The unit of S, unit of a complex power is the volt ampere. Unit of power, that is average power, is watt, and unit of reactive power is the var. Volt, reactive power na var, VA, volt ampere reactive. That translate to this. Clear? So we'll move to the lagging load and leading load. How to identify a lagging load and leading load. Load type. The two case arises. Let you have a G which is R plus Jx, and we are assuming that both R and X is positive. Okay, so lagging load, your Z is the R plus Jx. If both R and X are positive, this is called the lagging load. That means effective inductance is, effective impedance is inductive. Effective impedance is inductive, then it is called the lagging load. Okay, that means I lags V. Leading load, how, in what case we say that a load is leading? So G will be the R minus Jx. First you see the condition what I have specified. I am assuming that Rx both positive. Then in this case R minus Jx is the leading load, that is I leads. When the current leads, it is called the leading load. When current lags, it is called the lagging load. I leads V. For example, G equal to 10. Let us move some topics because we have described in the last class the basic. I forgot that to discuss the further, but I covered the power topics. Oh, anyway, how to identify a lagging load from the complex power? So for lagging load, your complex power, let's say S equal to P plus JQ. P plus JQ. Again, both P and Q are positive, greater than 0. Then for lagging load, simply S equal to P plus JQ. For leading load, S is equal to P minus JQ. This type of, for example, S equal to 100 plus J20. S equal to 100 minus, that is 100 watt, and J, that is the minus 20 var. Okay, so in the last class, okay, so actually I forgot to the cover of this. In the last class we have covered about the basic element, right? For example, element R, okay, and values, resistor, resistor values are voltage and current are in phase, are 90° out of phase and voltage leading the current, right? Then capacitor C, which is 1 upon j omega C, the impedance offered in the AC alternating current environment, and that will be the your current and voltage again out of phase, but current leading the voltage. So any combination of R, L and C you can immediately convert into the AC circuit or AC impedance circuit. All these are, then when you talk about the impedance, all these are in the ohm, but in the values it is ohm, it is Henry, it is farad or microfarad, whatever you say, right? So for example, you have been given a circuit like this. Okay, let's say it is 10 ohm, then your 20 millihenry, then 20 ohm, then 20 microfarad, and they have been given 100 0° volt, and your omega they have been given as the 100 radian per second. So you can easily fix it, easily calculate. R remains same. For example, L equal to 20 millihenry. So J omega L will be the J omega is the 100 and 20 millihenry is the 0.02, right? So you got 2J ohm. Similarly, capacitor has the value of how much it is, 20 microfarad. So 1 upon j omega c becomes minus j upon omega is the 100 into 20 into 10 to the power minus 6, that is minus j which is 1000. Okay, okay, you see here 30 is there and 10 to the minus is 1000 will come to the numerator upon 2, that is minus j 500, and finally thus now circuit becomes 10 ohm, 20 ohm, j2 ohm and minus j 500 ohm, and the voltage phasor. Once you converted into the AC impedance form, then you will do the as usual circuit analysis, whether you want to KVL, KCL, node analysis or loop analysis. Whatever you do, you can easily find out the answer. Any complex circuit, whether the parallel combination, series combinations, you can do as treating as a impedance ohm. For example, you want to find the current in this circuit. What you will do? You are seeing the simply it is a you can find out the Z total impedance faced by the voltage source. So Z will be the 10 okay, plus J2 parallel combination with 20 minus J500, and you will proceed like this, right? So after the finding Z, you can find I is equal to V upon Z, okay, and V is your 100 of 0 volt, and this Z is the whatever you calculate here, okay. So you can easily do any type of circuit, and you can find out the current phasor, voltage phasor, individual voltage. Once you find out the current, then here we will apply the current division, then you can find the individual current. What sort of things you require, you can easily find by putting the basic network theory relations. Okay, let us move to do some of the questions which appeared in your GATE exam. So you see here, it's a little bit small, I think. Okay, can I do anyway, let's start. A periodic variable x, is shown in the figure as a function of time. The RMS value of x is the, this is the this is to find the RMS value of x. Again you will write the, what is the RMS value of x? RMS x, RMS basic relations you first write, 1 upon period, integration over a period, x of t square dt. This is the basic relations. Then you have to identify t. T is the, clearly the time period is the t by 2, t by 2, and but x of t exists from 0 to t by 2, right? And you know the equation of a straight line, that is the slope. Slope is the t by, that is the 1 upon t by 2, 1 upon t by 2 slope into the t. This is the equation of xt, that is 2 upon capital T small t for small t from 0 to t by 2. This is, so now you put the values. So x RMS square is equal to 1 upon t as usual. You see that x of t exists from 0 to t by 2 obviously, and your integration also exists from 0 to t by 2, and the square of xt, that is 4 upon t square and t square dt, right? So 4 upon t cube, and the t square dt, integration of t square dt, how much? T cube upon 3 and 0 to t by 2, and ultimately what will get, 4 upon 3, sorry, not 4 upon 3, 4 upon TQ. 4 upon TQ into T, because you will put the T by 2 here, TQ upon 8 into 3. So you will get the 1 upon 6. 1 upon 6. So the XRMS, the RMS value of this XRMS is equal to 1 upon 6 root over. So you will get something like 0.408. GATE-2014. That is exactly 9 years back. Okay, hope you got it from the basic relations. Let us move to the next questions. Leading power factor, and the second one draws 10 kilovolt ampere at 0.8 lagging power factor. The complex power delivered by the source is, that means it is a gate one for again for the, so this is the beautiful code. So it says that there is a source, voltage source, which is 230 volt RMS. It has two parallel load. Okay, two parallel load. One, let's say load 1 and load 2. So load 1 draws how much? That is 10 kilowatt, 0.8 leading PF, and load 2 draws 10 kVA, 0.8 lagging PF. See, one has given in the watt, right? One has given the power, that is average power. One is observed, so delivered by the source, plus JQ. In this form we need to find out. So first we convert complex power for the load 1, then complex power for the load 2. So you know, just now we have discussed the power triangle. What power triangle says that if it is your P, it is your Q, you can easily find out the S, right? And they have been given the leading power factor. Then that means you have to have a negative reactive power. Lagging power factor, positive reactive power. So let us first calculate. They have been given the cos theta for load 1. Cos theta for the load 1, cos theta is the 0.8. So P already been given the, let's say P1 for the load L1. P1 is equal to 10 kilowatt. We need to find this Q. How you are going to find Q? P has been given and a power factor has been given. Just use the basic relations. That is your tan theta is equal to Q upon P, and Q equal to P tan theta. You have been given cos theta. How to find tan theta? Sin theta first, you find that sin theta. Sin theta is equal to 1 minus cos square theta, that is 1 minus point sin square theta, equal to 1 minus cos square theta, 1 minus 0.8, that is a 64, which is 0.36. Okay, that is sin theta equal to 0.6. So your Q you got is the, how much Q you got, that is 10 kilowatt into Q upon P, that is 6 upon 8. How much it is? 7.5 K var, VAR. So I can write S1, your S1, that is complex power for the load L1, is the 10 kilowatt, and it is a leading load. I have told you for leading load you have to include a negative sign, J 7.5 kilowatt, right, 7.5 kilowatt, or you can simply write 10 minus J 7.5 simply as per the, instead of writing individual, because its unit is volt ampere. So 10 minus J 7.5 kilovolt ampere. Okay, now come to the L2. L2 is the straightforward. So we go to the next page. We know that for L2 they have been given that is the, one second, L2, the power absorbed or power is the delivered, because the power delivered by the draws, okay, second law draws 10 kVA, 0.8 lagging. Ten kVA, 0.8 lagging power factor. So same way, power triangle, this distance has been given, that is magnitude of S has been given, which is 10 kVA. Cos theta has been given, this theta cos theta has been given. So simply your P power will be the S magnitude cos theta is 0.8. So 10 kVA into 0.8, that is 8 K 8 kilowatt, and what will be the Q? Q will be the S sin theta. Just now we have calculated sin theta, so 10 into 10k into sin theta is equal to 0.6, that is 6 k var, VA volt ampere reactive. So complex power S2, this is S2 na, S2 will be the P2, it is a lagging as I told you, plus JQ2, that is 8 kW, or you can say 8 plus J 6 kVA. And finally total power, because total power drawn by the two sources is equal to the total power delivered by the source. You see the question, the complex power delivered by the source is. Complex power delivered by the source S is equal to S1 plus S2, and we have calculated in previous page as S1, that is 10 minus 7.5. So 10 minus 7.5 kilovolt ampere, and this one is the 8 plus J6 kilovolt ampere. So finally 10 plus 8, that is your 18, and minus 7.5 plus J6, that is minus 1.5 kVA. So finally the answer is 18 minus 1.5 kVA, which is, what is your option here? 18 minus J 1.5 kVA, that is option B. This is a very fundamental question we have studied. Let us move to the, hope you understood this. So I expect that you should also work out all these questions on your own, so that you have a hand practice. That's great. Great, Harsha. Please learn whatever the my aim is to give you the best input what I have learned over the years, so that if you learn today and won't practice for tomorrow or for 1 week, then there is no use of learning. I request all of you, for your betterment, you should practice always, so that all the silly mistake is a mistake, but you guys these days, there is a term coined, everyone comes out from the exam hall and they claim that I did silly mistake 5 to 7 questions. These are not silly mistakes. This is a lack of practice, or you forgot some portion of your fundamental or conceptual things and you messed up the things. That usually happens and it's termed as a silly mistakes. So if you want to avoid the silly mistake, you learn, then apply. Don't think that I have solved, you have seen the answer, you have solved. You can solve a single question n number of times and you will learn n number of concept. Just remember. It's a beautiful question. Recently it has appeared in the GATE 2024, shown in the figure with the input Vt in volts. The sinusoidal steady state current It shown through the circuit, flowing through the circuit is shown graphically where T is in seconds. T is in seconds. The circuit element Z can be, okay, circuit element Z can be. So single element they have given, a capacitors and inductor with the values. So first of all, how to identify? The process is very straightforward. I have told you in the last class, if you remember. The reference 0, okay, see the input reference, the sine t, this is your sine function, okay, this is the input Vt, and the I, if you see clearly, I is starting at the starting zero crossing is the at t equal to pi by 4. So what you observe here, it is a leading or lagging. I is leading or lagging from voltage. 0 is here at 0 and the current 0 is at the t equal to pi by 4. Simply it is a lagging. And which type of element will induce a lagging current in the circuit? That is the inductive element. That means elimination A and C got over. A and C cannot be possible. So you left with the B and D. Now you will come to the amplitude factor. Your Vt is equal to sin t. So your omega is equal to 1 radian per second. Right? So current amplitude, the current It will be the, that is Vt upon Z, and the magnitude of current amplitude is the 1 upon root 2. Okay, magnitude of 1 upon root 2. So that means 1 ohm. How I can get the root 2 in the denominator in the Z? So Z can only possible if, because 1 ohm is given, so it should be J1. So J1 means inductor of 1 Henry. Inductor of 1 Henry. Another way you can also find what is the time delay. T naught, I have told you, T naught is the pi by 4. Okay. And omega that is theta naught will be the delay. So T naught into omega pi by 4. So you can easily write the, if they are asked, I think, if they have not asked, but sometimes they ask. So It will be 1 upon root 2 sin t minus pi by 4. The equation. So from amplitude condition you got the V. So only a simple conditions, and it is a beautifully, it is a 2-mark question. So how easily you can do actual things in the topics. Let us move to the next question. Fifth number question, you can easily say that it is a 2-mark question. It appeared in the GATE 2023, I mean this year, in the instrumentation, not EC. Okay, see the how simple question it is. The voltage source Vs, the trick point is the this internal resistance of 50 ohm. In a hurry, if you are in a hurry, you will see that 25, so you will forget 50 ohm, because this Vs has also a resistance of 50 ohm. You need to take it into consideration to get the current. So the voltage source Vs is equal to 10 root 2 sin 20,000 pi t volt. Has an internal resistance of 50 ohm. The RMS value of the current through R is in milliampere, rounded up to 1 decimal places. So I have told you how to convert into the impedance. So for L, so 1 upon 20 pi millihenry converted into the j omega L. J omega is your 20,000 pi, 20,000 pi into L na, L is the 1 upon 20 pi into 10 to the power minus 3. 20 cancel, pi cancel, 3. So J only J ohm. Then for capacitors 1 upon 25 millifarad, it is also minus J. You can easily see that it is simply reciprocal of this. Okay, J omega is the value L equal to C. So J omega L, if it is a J, 1 upon J omega C, that is 1 upon J omega C, because L and C equal, na? So it will be minus J. So total impedance faced by the, here the people do mistake. Total impedance faced by the source is the J minus J, because all are in series, J minus J 0, 25, 25, 50 ohm. And people will simply jump into the 10 root 2 upon 50. That will give you the wrong answer, because input resistance of 50 ohm. That is the trickiest part of this question. Otherwise, question is very straightforward. See, they have been given different figure without hiding. I mean to say, hiding 50 ohm resistor. So total impedance faced by the Vs is equal to Rs and 25 plus 25. Rs is the 50. So 50, 25, 25 is the 100 ohm. And the current will be the, I will be the 10 root 2 upon 100, which is 0.1 root 2. This is the peak value of the current, Im. So I effective or I RMS is equal to Im upon root 2, because this is the sinusoidal. So 0.1 ampere. But what they have asked, you have to say again, not the right, don't write 0.1, because they have asked milliampere. So milliampere means you need to convert into milliampere, that is 100 milliampere. Enter the 100 to get plus 2 marks. बच्चों clear है? Just think about how easy it is, but the trickiest part is the 50 ohm internal resistance. Okay, with this we end the AC analysis class. Now it is on your part that you should do lot of previous PYQs coming from AC analysis. Okay, some questions are directly from the AC analysis. We have learned some questions from the AC analysis with some application of the that is Norton theorem, Thevenin theorem, maximum power transfer theorem. That will be looked after in the next class. We will be discussing the network theorems. So before network theorems, why I have discussed the AC analysis? Because so we don't have any boundary or any restriction in discussing the Thevenin's theorem. Will apply for the both the DC and AC, so that we can learn the network theorems with all the concept we have learned, whether it is AC or DC. And I hope you have understand and learned some new things today, and hopefully you add to the your you can say the knowledge library, because the success in the GATE exam is the how much knowledge you are adding to your knowledge library each and every day. That is the success mantra. You can say that if you learning every day, practicing every day, that inertia will be carried into the GATE exam, and you will feel much more confident. Confident will come from the learning the concept and practicing. Okay, when you learn the concept and apply that concept in the doing the question, so automatically your confidence will be increasing day by day. Don't, one advice for you, this is the time you should work out in a different way. Any problem, don't simply jump into the solution of that questions. That is a very big bad habit, and people try to learn from the solution. It's a very ridiculous things. It is I am sorry, but it is true. I don't want to mock any students, because they are learning, they are putting their hard effort, but hard effort should be smart. You should apply in a smarter way, not that just sleeping in the bed and looking at the solution of a questions. If you don't effort if you don't put your effort for your learning, then how can you expect that a good rank in the GATE? This is the fact. This is the open fact. If you like my words or not, but it is a fact. You cannot get the good rank just by sitting or looking at the solution. You should try. You should try in the different angles 2 to 4 times, and then if you are still you are not able to get, then you can look for the solution, or give me that is, you can discuss in our group so that I can have a say for that questions. So that should be in your mind actually to get the success. Okay, practice every day and learn every day. Just keep in your mind, and definitely you will get the success. Success. Many people are very narrow, that they think that if I don't score well in the GATE exam, then I could not get the success. That is a 3-hour exam, and definitely if you go with the confident and you can say you can say equipped with all the basic, then definitely you will able to score 50 to 60 marks, and that will be helping you getting the admission in the IIT ISC. But even if you score in the range of 40 to 50, don't think that you did not get success. That is a very relative exam, and you learn the many things that will be applied in some other part of the course, or you can try in the offline exams. So learn. There is no alternative for the learning the new things. If you can't be a good learner, then you cannot be a success in cannot get the success. You may do bad in a GATE exam, but if you have learned well and you have learned all the basic, then definitely it will be helpful in some other form of the career in your life. With this we end the class. See you in the next class tomorrow. Thank you for watching the video. Good night.